size. Yeah.
And let me just sign in here. So what we've done is we've developed this bot internally on AWS. Ignore the cost up here because the cost here, we're looking at the token count here for input and output. The cost, we've got some work just to do on the cost. We're just not calculating this correctly at the moment. We're picking up the wrong metric for some reason. We've also got dark mode here, light mode, dark mode, which is one of the most important features in any application. Um, we've built it in so what you can do is you can select one from any number of models and actually run your prompt against any model that is available within AWS. We've selected, I think it was 10 last count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so we've got 10 LLMs to choose from here. These have all been provisioned as serverless LLMs in Amazon Bedrock. I'm going to just jump into Bedrock in a second and show you what else we can do on top of this, which we haven't actually implemented yet. But there are built-in guardrails within the LLMs already, and I'm going to show you how we can implement some additional guardrails. So if you want to just interact with any LLMs, you would just select the specific LLM. If you're deploying this internally, and we can deploy this for customers internally on their own infrastructure, what you can do is you can reduce the costs of any query that you run against the LLMs by selecting specific lower cost LLMs at the back in the background. So, for example, Claude 3.7 would be one of the more expensive models, and the Amazon's own models like, for example, Titan, like Nova Pro. These are all Amazon's own models, which are slightly less costly. We've got Llama 3.3. We're about to implement Llama 4, which I think they've just last week they just released that through Amazon Bedrock. They had it available in SageMaker, but as of last week, they've implemented it with the serverless feature within Amazon Bedrock, so you can just deploy it and then you don't pay anything until you actually start using it. So let's just run a query at 3.7. Tell me about Amazon Bedrock. Okay, so obviously it sends the query off. We've got a Lambda function running in the background, which runs the application, and then it queries it, sends the query out to Amazon Bedrock, and then pulls the response back. You can specify the token size so that if you want to restrict the usage for employees, let's say you're deploying it internally, you can restrict the usage for employees by limiting the amount of output tokens you're allowed to utilize. And similarly, you can input the number of input tokens as well. I think we have a limit of about 1,000 on here. As you can see, it's quite fast. If we then go to a different model, like Nova Pro, for example, this will be a slightly cheaper query. I'm going to ask it the same question. And it'll send that off and it keeps it in the same. As you can see, you've got multiple LLMs, but they're keeping the output in the same chat history, which is quite handy. Um, so let's have a look. Where are we here? Amazon Bedrock fully managed service. So you can see the response is pretty similar. Um, Let me just try run another one. Llama 3. Let's run it again. Okay, yeah, that's why I was getting confused because it's putting it at the bottom. There we go. So the outputs are slightly different in output style, depending on the model you select. But it stores it all in the history. So you can insert a code block here as well. If you've got a code block to insert, JavaScript, Python, you can insert it all in the prompt window here. So we've implemented those features. You can export all your data, so it exports into a file, flat file, as a JSON on your local machine. If you want to start a new chat, start a new chat here. And then if you look at your history, you can see your previous conversations are stored here. Currently, these are stored in the browser cache. which is a bit of a limitation. If you move from machine to machine, it doesn't take your conversation history with you. But if we have customers who want to implement this, we could implement this with the DynamoDB conversation history store in the back end. So this will be then taken from browser to browser wherever you go. So let's go back to that new chat, and then tell me how to set up RAG on Amazon Bedrock. So if you just run your queries, obviously when we're running these queries, it's not sending it out to the public LLMs. It's sending to your own version of that LLM. So it's all kept secure and confidential within your own AWS account. That one's taking slightly longer. What you can do on top of this as well is you can implement, um, I don't know what happened there. I think that's a failure in the model on the back end. That's interesting. Okay, I think that's a limitation of the actual Amazon Titan model. Let's just run that against another model. Let's run that against DeepSeek. See, so DeepSeek, as everybody probably knows, is like the Chinese version of OpenAI. It's trained on pretty much the same data set by all accounts from what we can ascertain. Let's leave that running as well. So what we can also do is we can set up guardrails within. This is what I've done is I've just jumped in the Amazon console now. What I'm going to look at here is setting up a specific guardrail. So if you've got individual requirements to block users from doing certain things within, your own deployed LLMs, you can do that in here. It's really straightforward to actually create a guardrail. Um, let's call this guardrail 001. Okay, internal company LLM policy. So if you've got an internal company LLM policy and you've got requirements to stick to specific prompts or what you can and can't do with the LLM, you could align this guardrail set with that particular policy. If you haven't got a policy, we can help you create one. And you can see you've got a bunch of different options down the side here. We'll go through this through the wizard one at a time. Configure harmful categories. So you can see you've got a whole bunch of um, sensitivity for all of these filters. So you can, for example, hate, insult, sexual violence, misconduct. You can set, you see we've set these really high. The default is high and to block. So if it sees anything that triggers one of these filters, it will just block it. It will say, and you can see, I think we go back to the previous screen, you can see the statement that comes out is, sorry, the model cannot answer this question, but that's configurable. You could put like, comma, due to company, oh, I can't spell today, company LLM policies. And then we could set all of these prompt attacks. If you're not familiar with prompt attacks, come and speak to me. We can tell you all about that. You can see these by default are set high. If we go to the next one here, we can add topics in here. Like I used one earlier, dog walking, right? So if you've got, let's say you've got an internal company cat that doesn't like you querying stuff about dog walking. Dog walking is not allowed. I can't type today because the company cat doesn't like it, right? So what we can then do is we can block any input or output related to specific phrases like, where can I walk my dog? And you can add various different iterations of this as well. Are there any good dog walking areas close to the office. So you can see you can build a set of denied topic phrases and confirm that. And then we can put profanity filters in there. You can either use custom words, so you can actually type um, your own swear words or profanity into the words and phrases. So, do you want to give me a swear barrel?
No, I'm at work.
Okay, let's use something that's not going to trigger any alerts.
There you go.
Bloody hell, Harry. Right. So you can see, and you can put like a whole bunch of, you can actually import a file. If you've got all your swear words in a file for some reason, you've got a file full of swear words, or it's in a memory
Profanosaurus.
bucket. Say again?
The Profanosaurus.
Yeah, yeah, exactly. And then one of the good things here as well is you can block or mask PII. And what we like to do is just select all of the PII types and mask the information. You see, so you can just mask it. You can edit these and make these block rules. So if you want to block them specifically, explicitly rather, you can do that. If you've got a specific regex patterns, which are like maybe credit card number patterns, things like that, social security, you can put these in as specific regex patterns and adds those into your block or your mask as well. I'm not going to put any in there. Um, and then the grounding here, I'm not going to select these options. These are optionals. But if you've got like a database of internal company information, and when you want the answer given back that aligns with your internal content, let's say you've got company policies or documentation that you need to refer to make sure the answers coming back are, as it says here, grounded in truth. So basically, what you do is you would link your internal database of information. For that, you would need to create like something called a vector store, and the vector store would then be linked back to the Amazon Bedrock LLM, and then uses something called retrieval augmented generation RAG. It would then check that answer coming back with the content in your internal database to make sure that the answer the LLM's giving you is actually based on fact from your own documentation. If you've got that available, if you haven't, then it would just you just leave it blank, and you'd have to hope that the answer comes back is based on fact with the training data. Obviously, you're probably aware that sometimes you can get hallucinations, so you have to check everything that you kind of output from an LLM. But having grounding checks does give you that level of kind of additional confidence that that answer coming back is correct. And that's it. That's how you create a guardrail. And then you create that guardrail. It's given it a name, and you can see all your guardrails and apply those to your particular applications or LLM deployments throughout Bedrock. Let's jump back to this and see how it's got on with this second time. So this is the output from DeepSeek. You can see it's slightly differently formatted from some of the other ones, like a brief description of the model
Oh, okay. Yeah, perfect.
in here. So powerful AI model, strong reasoning, language and code. Right, and if you go to one of these other ones, let's see what it says about DeepSeek. Reasoning, knowledge-based responses, Mistral, efficient model, strong performance on various neuro-linguistic processing tasks. Titan, cheap. Cheap model for general text
Interesting.
and text generation. But yeah, so like I mentioned, the price up here is incorrect. But the token count is correct. But if we have a look, I did open the cost dashboard. So if you have a look, this is the Cost Explorer in AWS.
Mm.
Ran various different queries, prompts on May the 9th, as you can see. And you can see that the prompts that we raised, which was about the count of tokens was actually greater than this. We had like about 447 tokens. I reset this the other day just so I could kind of show this. But we had like something like 8,000 tokens plus 400 input tokens. And when we looked at the Cost Explorer costs here, you can see combined costs of all of the models. I mean, some of them are not even showing up. The cost of some of them are so small that they're not even showing up on the cost explorer. So I think from that point of view, you can see it's obviously if you factor in the implementation cost for us to come and implement it for a customer, that's a different bucket. But the ongoing running costs for this, if we were just to deploy and hand off to a customer, the ongoing running costs would be, depending on the usage, would be easily trackable, easily traceable through cost explorer, but kind of I would say much lower than implementing something like OpenAI at $200 a month per user. And Copilot even, building Copilot, which is also OpenAI in the background. So you can then just see that it's quite an efficient and cost-effective way of deploying your own secure, private, personalized chatbot for not just one, not just one LLM, but multiple LLMs in the same chatbot. Whereas obviously all the others, if you have OpenAI, you only use OpenAI. It has obviously some more cool features in the UI, like Claude does as well. But each one of those you pay per LLM, right? You don't have a single consolidated view to use to give your employees just a single interface to deploy it, which is what we try to do here. Just one single interface, multiple LLMs, and then being able to track it to the user and to the cost as well. Which obviously, once we sort this calculation out, that will be accurate as well, and dark mode as well. And just one thing else is I'm just gonna what is a LLM guardrail? There you go. Just for people who don't know what guardrails is or guardrails are. Let's see how quickly we can answer that again. Let's see how the tokens, input tokens. There you go. How many output tokens is that? About an extra 100 or so tokens. And if you do the calculation on those extra 100 tokens, that's minimal. But yeah, guardrails, safety mechanisms or constraints implemented to ensure that large language models operate within appropriate boundaries. These guardrails help prevent harmful, biased, or inappropriate outputs from AI systems.
Pretty powerful. Thank you. I think it's really important for people to kind of have that ability to control those LLMs, where people can obviously just go to websites and use them themselves and inadvertently be putting private company information on there without really thinking about that. Obviously, having all this in a central location means that people kind of can move around between those models and work out what's best for them, rather than just kind of like jumping around from different websites and all your information being kind of
Exactly.
released across different models across the internet, kind of thing. Public
Exactly.
LLMs across the internet.
Yeah, and we can define an architecture which actually means this doesn't even go across the internet, the queries, because obviously the URL here at the moment we've configured is internet URL. It goes to Amazon Web Services through the Amplify service. So we've built the application on Amazon Amplify. What you could do is just make sure this URL was restricted to an internal VPN, let's say, and then you would deploy this bot into Amazon Web Services, connect your local office to Amazon Web Services over a private VPN, and then all of the traffic that's going to and from this bot, again, that wouldn't even touch the internet, or it would be actually encrypted and secured across the internet through a VPN connection. And so all of your users would then use this and not go out to the external public LLMs.